All right, and welcome to Unit 2, Foundations of Chemistry, Chemical Reactions and Nomenclature. So this is the first part of Unit 2. There's three parts. There's chemical reactions and nomenclature. There's the mole, and there's stoichiometry. So let's get started on this chemical reactions and nomenclature. Nomenclature just means how to name things. All right, so we're going to start off with what is a chemical change and what is a chemical equation. All right, so we've got two types of change that we're looking at. Physical change. In a physical change, the matter itself doesn't change. The molecules don't change. Only the arrangement of the molecules. So physical change, the molecules don't change. The physical appearance of them does. Usually we associate physical changes with changes of state. But a physical change is just, breaking an ice cube into two pieces. It was one piece, it's two pieces now. There was a physical change. Physical change of water into ice. So we started with water. It's H2O here. It is now H2O here. It was liquid, that's the physical characteristics. Now it's a solid. So there was a physical change, but it's H2O before and it's H2O after. Chemical change, on the other hand, chemical change is the molecules themselves change. So one molecule becomes a different molecule. But the atoms themselves don't change. The atoms don't change. Right, what was a hydrogen atom at the start is now a hydrogen atom at the end. So the molecules themselves change. Now, this means we get new substances, right? We start over here with our reactants. And we come over here and we get our products. And the products are new substances. Now, what do we call a reaction where the atoms themselves change? Those are called nuclear reactions. So physical change, the molecules stay the same. They just change states. Chemical change, the molecules change, but the atoms don't. In a nuclear change, the atoms change. All right, so what are some indicators of a chemical change? Well, there's a lot of different indicators of a chemical change. A lot of times in a chemical change, a gas is given off. There's often a change of color. Sometimes you get a solid that we say precipitates out. Often you get a temperature change. Right? A chemical reaction can be either exothermic or endothermic. And that would be a temperature change. So it feels hot, it feels cool. These are the primary ones. The gas given off, sometimes you can smell that gas and it might smell bad, but these are the primary indicators of chemical changes. Sometimes explosions can be an example of a chemical change. Something really violent happens. All right, so chemical equations, which you should be very well versed in. If chemical names and formulas are the words of chemistry, then chemical equations are the sentences. A chemical change shows the reactants, the starting materials, and the products. New materials that form involved in a chemical change. Equations also include subscripts that indicate the state of the substance, solid, liquid, gas, or aqueous solution. Aqueous solution just means it's a chemical in water. It's dissolved in water. So, here's an example of a chemical change. Well, let's do this chemical change. Hydrogen peroxide into water. So we've got H2O2 will give us H2O plus O2. And of course, we always need to balance these guys. So this is going to be 2 and 2. And the H2O2 is most likely going to be a liquid. The H2O will be a liquid. And the O2 will be a gas. So that's what these little subscripts mean. This means how many molecules of each there are. There's one O2, two H2Os, two H2O2s. If you look over here, we've got two H2O2s, two H2Os, and one O2. Balance equations. The law of conservation of mass. The mass of the products is equal to the mass of the reactants. So no mass is gained or lost during a chemical reaction. In a chemical reaction, atoms are not created nor destroyed. They are only rearranged. So the number of atoms of each type in the reactants has to equal the number of atoms of each type in the products. So if we look here in our reactants, we have carbons, hydrogens, and oxygens. We have one carbon atom, we have 4 hydrogens, and we have 2 oxygens. And on our product side, we have carbons, hydrogens, and oxygens. Right now we have 1 carbon, we have 2 hydrogens, and we have 3 oxygens. And hopefully you remember this from last year when we did all of this. We just need to match them up. So the carbons match. That's good, carbons match. Let's go to the hydrogens. Hydrogens don't match. So we need 2 of these. Now that 2 of these, now we have 4 hydrogens. Each water molecule has 2 hydrogens, and there's 2 water molecules. So we're now at 4 hydrogens. But we've also changed the number of oxygens. 2 oxygens are in the carbon dioxide molecule, and now 2 water molecules have 2 oxygens, so we now have 4 oxygens on this side. 2 and 2 is 4. So we need, our carbons are still balanced, our hydrogens are balanced, we need our oxygens to be balanced. So we need 2 oxygen molecules here, and that will give us 4 oxygen atoms. Now everything is balanced. Fill in the blanks with 1s, and we have balanced that chemical reaction. All right, so looking at the steps for balancing equations. Write out the unbalanced equation first. Change coefficients to big numbers in front. You can't change the formulas to little numbers. Check to make sure that you have the same number of each type of atoms on both arrows. Count the atoms. Hint, in a complicated reaction, many elements balance oxygen last, hydrogen second last, and all other elements first. We also have to remember the other rules that we found, that we remembered, in ionic chemical reactions. You keep the polyatomic ions together, and In reactions where there's H2Os and OHs, we often rewrite H2O as HOH, and then we balance the OHs. So let's look at these. We've got 1 P and 2 O's. We've got 2 P's and 5 O's. All right, so let's balance this. First thing, I write a 2 here to get my 2 P's balanced. All my P's are balanced. Now I have to get my O's balanced. I've got 2 and 5. I can't do 2 times anything to get me 5. Well, I can. I can make this 2.5. 2.5 times 2 gets me to 5. Everything's balanced. Except we need whole number quotients here. So what we have to do is double each of these to get 4, 5, and 2. And that'll work out. 4 phosphorus, 5 oxygens gives me 2 diphosphorus pentaoxides. All right, and the second one, we've got 2 K's over here. We've got a K over here. We have an O, 2 O's over here, 1 O over here, 2 H's, 1 H. Now in this one, we find our OH here. So we rewrite water as HOH. And I'm going to say something in this equation. This doesn't matter. This doesn't do anything for us. It just doesn't. Normally, if there is a base and a salt, we have an acid-base reaction, this will work for us, but this is not, so this won't really work well for us. So we have 2 K's here. We have 1 K here, so we're going to put 2 here. Now we have 2 K's, 2 K's. We have 1 O, 2 O's here. We have 2 O's here. 2 of this molecule gives us 2 O's. We have 2 hydrogens here. Well, we have 2 hydrogens here. This is now balanced, 1, 1, 2. All right, next one. NH42CO3 gives us NH3 plus H2O plus CO2. All right. Let's see what we got. We got 2 N's here. So we're going to need 2 N's here. Let's put a 2 here. And now we've got C's. 1 C, 1 C. That's good. We've got 8 H's. Right? 4 times 2. 4 times 2 is 8. We've got 6 H's and 2 H's. Hey, that's perfect. We got the right number of H's. O's. We have 3 O's here. We have 1, 2, 3 O's here. Everything's balanced. 1, 2, 1, 1. Last one. Copper reacts with silver nitrate to produce copper 2 nitrate and silver. By the time you're done this unit, you should be able to do equations like this pretty easy. Copper is just Cu plus silver nitrate. Silver is Ag plus 1, and nitrate is NO3, 1 minus, so this is AgNO3. Ag is a 1 plus and NO3 is a 1 minus, so this is ionically balanced. We have to do that first. We're going to produce copper 2 nitrate, Cu, and this is a 2 plus charge, NO3. NO3 is a 1 minus charge, so we need 2 NO3s, plus silver, Ag. You should be able to read a chemical reaction like this and write one out. Now, to balance this, when we're balancing this guy, we treat our NO3s as a whole thing. Okay, so we have 1 NO3 here, 2 NO3s here. All right, so 1 Cu, 2 Cus. Or sorry, 1 Cu on this side, 1 Cu on the product side. Cu is good. 1 Ag, 1 Ag. Silver's good. 1 NO3, 2 NO3s. Not good. So we put a 2 in front here. Now we have 2 NO3s and 2 NO3s. But now we have 2 silvers. So we have to put a 2 here to get 2 silvers. 1, 2, 1, 2. That is the balanced chemical equations. All right, I hope this is review for you, because in Science 10 you should have become a master at balancing chemical equations. And if you have, you're in good shape for this. All right, thank you for watching.